Alright, hi folks, Almanzo again with a video upgrade. Sean, thank you. I'm now recording in 1080p. I may have been before, but I was on an iPad, and I can actually see myself now. Here we go. Alright, so what we're going to be doing, or what I'm going to be doing, is I'm going to be turning this into this. I'm going to be machining in the 25-degree angle onto these neck cups. Okay, so bear with me. The idea here is that this needs to be within plus or minus a 5/1000th of an inch, 850 thousandths. This one is currently 851. So pretty darn good. Considering that there are some variables, the diameter of the material can vary slightly. That will throw off the measurement. How it sits into the fixture, that can vary things. Thermal expansion of the mill, thousandth here, thousandth there. You just got to work with things. All right, so here we go, folks. And let me grab my monitor here. There we go. And I'm watching you, watching me, so I'm making sure that I'm in frame here. Alright, so I'm going to set this down over here. And we're going to go to the fixture here. I have this mounted on a tripod now, so I can get you closer to the action. And I'm going to try my best not to, do this sort of thing. So, all right, let me see here. Okay, so I've already cleaned this out. I've blown this out with compressed air. This is a fixture that I made many years ago, but I've since upgraded it. Originally, it was held in my vise, but the vise, it's very hard to get it level, so I trued up the bottom of this block so that it's perfectly level when it holds the part in here. So, let me see. So we start with this outer casing, outer housing in the core. So what I'm going to do is remove this screw that holds these two together. And I'm going to set that off to the side. Okay, and I will be, if I remember, I'll show you the inside of there so you can kind of see what's going on. Nothing dramatic, but so I'm pushing the core out, and there's the core. So I'm going to set the core over here, make sure there's no swarf where I set it. Check the inside. Looks good to me. Okay, so now what I have is I have the 1/2 inch diameter nylon ball that I've machined so that the screw goes through there. It basically just slides through, but it catches a little. But yeah, that's the basic premise of it. And of course the head of the socket head cap screw goes below the surface. So I have my witness mark. I want my witness mark coming out towards me. Place this in here very carefully. Okay, looks good. It's not binding up. So what I have to do is I have to insert this ball into here. It's a very tight fit. And push that through. Okay, I push it through and I pull down and I make sure that that is seated in there completely. And the other thing I'm going to do is making sure that that screw is coming out straight. Okay, looks pretty good there. So there's what we basically have. You'll see that sticks out the bottom. And the fixture's been designed to accommodate that. So, I'm going to put this in here. And again, I'm going to try not to get in the way, but it's somewhat inevitable. So, okay, I found my threaded portion, and I'm going down with this. Okay, and right about there I'm bottomed out. Now what I'm going to do is I'm going to insert an Allen key. You see how that's angled? I want this straight, so ballpark, I want it straight right about there. Yeah, it looks pretty good. Pull this back out, and now I'm going to tighten it down by holding this outer housing. And there we go. And I have to tighten this down pretty good. I don't want this thing to move while I'm machining it, for obvious reasons. Okay, so that's nice and tight. Now, the outer core, the core, make sure there's no swarf. Again, align my witness marks. Put this down in here. Use my centering tool. There's the hole. Move that. There we go. Now, the 632 screw now goes in. Just like this. Very simple, very easy. Of course, this fixture was machined so that it holds everything very tightly and at a 25-degree angle from vertical. So now, I'm going to see what my height here is for my Z. Make sure that I need to go up a bit higher. Oops, there we go. Just to make sure I clear that. Now I'm just going to go down and touch it. Touch the top of it. Right about there, 523. That's what my digital gauge is reading. Back off away, and I'll start out at 500 thousandths, or a ½ inch. Right about there. So I'm at a ½ inch. What I want to do is I'm going to go down until this hits 0. I'm going down each time 50 thousandths of an inch. I'm using a 4-flute end mill. I do not want to remove any more than that. I don't want to put too much stress on here or hog out too much material. You know, put stress on the machine, so on and so forth. So I'm running at 1800 RPMs. And here we go. Just gonna make sure I got that tight. Yep, that's nice and tight. Okay, and here we go. And I'm dropping down to 450. Or right about there. You can see when you first start, you're not removing that much material. Go down to about 400. Down to about 350. About 300. And they're about 250. I'm using a ½ inch diameter end mill. Down to 200. And this pass I'll be removing material from the entire piece. Go down to 150. Down to 100. As you can see, I'm not going terribly fast with my feed rate. Okay, I'm going to go down to 50 thousandths. Now I'm going to go to about 20 thousandths. As I get closer to my target, I want to be less aggressive. Okay, now I'm going to take it to 10 thousandths. Now one thing I should note here is that this will machine a slight amount off of the socket head cap screw. When I get down to my target. Now, what I'm going to do, I'm going to take this right to 0. Very carefully. I've actually locked the machine down. Okay, here we go. Now this is where it will mill some off of the cap screw. And there. We are done. Okay. Unlock that. I'm going to take this back up. Now on this one, it did not hit the top of the cap screw. That's because there was a slight variance in drilling on these. And it's literally just a matter of 5 thousandths of an inch or so, if whether or not you hit that or you don't hit it. I'll show you on this one that you can see the flat, possibly. I'm looking here. You can see the flat machined into there. It's simply a few thousandths of an inch difference when drilling this cross hole. Okay, so here we go here. Remove this. Now this is where I stress that you don't want things to be a press fit. Because you have to get this core out of here, and as you can see there's only one way to do it. And that is with a pick tool like this. Or a dental pick will work. Okay? I'm going in the hole, and this thing's going to pop straight up. So I apply a little bit of pressure, and there it went. I'm going to work it a little bit, try to get that to pop out further as far as I can. Right about there is about as high as it gets. It's not a whole lot. Okay, so grab a pair of hemostats. I'm going to gently grab this and pull straight up, wiggle it a little. When I get it up some, I'm going to get down, get more. There we go. There's the core. I'm going to set this right here. Actually, I'll just show you on camera. You can see how small these darn things are. And how precise everything needs to be. So, there's that. Okay, now we come back here, we unloosen this. And we run this screw back out. And there we go, screws loose. Okay. Now what I'm going to do is I'm going to grab this outer housing. It's pretty darn tight in here. There we go. There's the outer housing. Alright, so there's the outer housing. In order to get this ball out, again, it's a precise tight fit. I'm just going to push down on here and it pops. Okay, then I take something to just kind of push that all the way out. And there we go. So, if everything else is right, this should be right around 850 thousandths of an inch. And let me grab my calipers, since apparently I moved them. Okay, so within plus or minus 5 thousandths of an inch, this should be 850 thousandths. This is a little bit difficult of a part. Right there, I got 851, which is exactly what I got on the other part. Okay, that's fine. Like I said, thermal variances in machining, you know, just whatever. Please ignore that sound, it's my furnace kicking on. Even El Monzo needs heat. So, there we go. Okay, so I know that when I put the part in the jig, I don't have a witness mark anymore, but I know when I put it in here, the screw went in from this side. I take the core, I carefully put it back in here. And again, these are precise tolerances. Almost got it. There we go. There it goes. Make sure to get that hole reasonably lined up. Again, use my alignment tool. Go down in here. There we go, like that. And now take this screw. I put it back in here. Give it a little wiggle. And there we go. And right on through. Let me just get this a little bit easier to do. And there we go. And let me move this here so you can see that It's very, very precise. Again, forever married. Okay, and as promised, since I have this on a tripod now, I can now move the camera and I can show you down into the fixture. That's how that's designed. So yeah, so that's about it, folks. Alright, and I guess you can see me. I see me. So there we go. Take your time. It's a pain in the backside, but it can be done. Alright, this is Almanzo saying bye for now, and I hope this helps. Alright, here we go, and the monkey pushes the button.